Hi everyone, welcome to episode 2 of the Barber.ai podcast. I'm Ishita, co-founder of schooluniguide.com, an AI-powered platform that helps parents and students navigate their educational journey through smart search, comparison tools, and AI-powered personalized school and university recommendations. In today's episode, we're diving into AI governance and its growing impact on two critical industries, education and genomics. Joining me is Nidish. Nidish is a Cornell University graduate and currently a software engineer and Scrum Master at Omnitier, a company at the forefront of AI-driven genomic data processing. Together, we'll be exploring the intersection of AI, ethics, and regulation, how it's shaping decision-making in both classrooms and clinical labs, and the challenges and opportunities that come with it. So without further ado, welcome Nidish. Nidish, it'll be brilliant if you can give us a brief introduction to yourself and what your experience has been like working at Omnitier.
Yeah, happy to be here. Hi, I'm Nidish. I work at Omnitier, as you previously mentioned. I'm a Cornell University graduate with a degree in electrical and computer engineering and computer science. At Omnitier specifically, I work as a full stack software developer, so that involves both front end and back end work. So honestly, my entire job is a lot of code, a lot of specifically software development. Omnitier itself is actually a bioinformatics company, as you previously mentioned as well. We work in gathering data from, say, research centers, hospitals, basically any sort of field that is able to offer genomic data. We create an algorithm that processes that data and provides predictive detail, such as possibility of disease, any pathogenic or likely pathogenic variants. And in that actual algorithm, we use a lot of ML, AI, and other algorithmic processes.
That's really fascinating. I especially am really intrigued with the way you're leveraging machine learning and AI, especially in the context of genomic data. So that naturally brings me to our first question, which is how exactly does Omnitier utilize AI in genomic data processing? And I guess beyond just the technical implementation, what role do you think AI governance plays in ensuring that this very powerful technology is used responsibly, especially given, the complexity and sensitivity of genomic information?
Sure. So a lot of AI and ML-based systems are heavily weighed on data. So the more data you're able to feed it and the more examples of what you're exactly looking for you can feed it, it's able to more accurately reflect exactly what you want. So for example, a very simple AI model, one of the first ones that was ever created was an image processor. So essentially you would say you wanted to find a specific item in an image. You would basically give the AI or ML model maybe 100 or 100,000 images of this specific item, and then say, okay, here's another image that we haven't shown you. Can you find this image in that one? And through machine learning, which is really just data processing, it identifies patterns that it finds in all those 100,000 test data images that you find and looks at the new image and sees if it can find that. So similarly, in at least the genomic space I work in, we feed it data that we know is pathogenic. We know has, say, diseases like leukemia or whatever we're looking for, whatever specific disease we're looking for. And we say, okay, here's a brand new patient that we've never seen before. All we have is their genome sequence. Can you find any similarities between the two? Now, obviously, a human would be able to go in and do that, but a computer is just so much more efficient. So it would be able to process that, find the specific variants, that have a high likelihood. And, depending on how much data you give it, it can give you a probability of, say, 80, 90, 95% match or not match or whatever you're looking for. In this particular algorithm, since it's feeding off of patient data, hospital data, genomic data, that is highly sensitive information. And at least in the US, where I'm based, we have a lot of laws about privacy and all that. One that I'm sure you're all aware of is HIPAA. HIPAA is basically the cream of the crop for privacy in the medical field. Basically, a lot of the data we want to obtain, genomic data to put in our algorithm from the US, is blocked because HIPAA is fully on a voluntary basis. And a lot of people these days, are very pertinent on their privacy laws, and they don't want to have their data readily available like that, which is of course their option. But so a lot of our data actually is from overseas sources. We get it from Japan, a lot of places in the Middle East, a lot of these places where laws aren't so strict, or even places like Japan where they do genetic screening on almost every baby that's born. So that we have a lot of data that's available there.
Makes a lot of sense. Especially, I found it really interesting how you mentioned how crucial high quality data is in order to train these models with accuracy. And just stemming on from that, with AI feeding off such sensitive medical information, especially in genomic data, and alongside this, the rising scrutiny around high risk AI, do you think that AI in genomics should be classified as high risk? And if it is, how do companies like Omnitin navigate, for instance, the compliance challenges surrounding this, whilst at the same time ensuring that they continuously foster innovation?
So, like I said, AI is specifically in at least my field very high risk. I would say. Of course, there's a widespread use case for AI. Like I said, like the image processors. There, you can basically have a machine learning algorithm learn anything really. If you're looking for something in audio, looking for something, you see Chat GPT these days, where it has an LLM, which is a large language model, basically is able to understand English language through I can't even seem to predict how much data they probably fed that. But yeah, so high risk AI really comes into play when you're having, say, a data based model access information that is sensitive. So obviously, patient data such as genomic data and any sort of health history and things like that, that's definitely sensitive. Other possibilities could be, say, data that has images that aren't supposed to be like sent out by certain people. They're supposed to be, say, legal documents that shouldn't be seen, like things like that. Basically, any sort of confidential information should never be put into an AI without at least some sort of evidence that that AI is able to parse through that data without storing anything.
Yeah.
So a lot of AI models, say like the image processor, like the audio processor, after they come to a conclusion and the human goes on the interface and says, yeah, that's right, you did it correctly, thank you, or no, you didn't do it correctly, it will take that into account in itself and keep that in its data store. So now I know it can even better work on the next thing. That's where this high risk AI, in at least my field, comes into play, because we don't want to do that. We have a lot of certification in our particular algorithm that it is based on a complete public record, and none of the new data, new patient data, or anything like that gets stored in its algorithm. It will always revert back to its original. And that's sort of like, we discuss it as a positive cost of data privacy. So it's obviously every human doesn't want their data out there, and that's a big thing in the United States. So we ensure that that doesn't happen. And even though it's a cost to our algorithm specifically, because it would obviously benefit from more data, I think that legislation, at least now, is good, because it's very hard until more legislation or more specific legislation is in place to say, okay, this, you have to have evidence. You have to, when you release an algorithm like this, you have to have evidence that it does not store any data or anything like that. I think the current legislation is fine. I guess moving from that, how do you see the potential for AI in education? Would you say that's high risk, or do you think that there are any unique challenges that you might face?
Yeah, that's a great question. And I think to answer that, just before we answer that, I think it would be really worthwhile kind of explaining what are the different categorizations of AI. So under frameworks like the EU AI Act, which currently in the UK is aiming to align with in many ways, AI systems are categorized by risk levels. So right at the bottom, we have what we call minimal risk. Then we have limited, high risk, and also unacceptable risk. And now this is based on how much they can impact fundamental rights or safety. Now, when we look at the education sphere, one area that I think definitely falls into the high risk zone is automated exam proctoring. So now this is when you've got AI systems monitoring students during online exams. So whether it be through webcams, screen activity, or even keystroke patterns. And also some of these systems can also go further with facial recognition or, eyeball tracking to flag things like looking away from a screen or whispering. And now, while that sounds advanced, it definitely does raise very serious concerns. So First, I think the obvious being the privacy side. You're collecting huge amounts of biometric data like facial scans and behavioral patterns, which is extremely sensitive and could easily be misused or mishandled. When we think about really young children that are being, I guess, in a way tracked in these online exams, it can be quite risky. Then I think there's also the big issue of bias. So these systems have been heavily criticized for disproportionately flagging neurodivergent students or students with from racial minority groups. So a classic example is, for example, a student with ADHD might fidget or often look away, and the AI could definitely misread that as suspicious behavior. So it's extremely important that these models are trained on truly diverse data sets. And if they're not, there's a real risk of very unfair treatment and unfair decisions coming out of them. And finally, I think there's also a great lack of human oversight. So if a student is unfortunately wrongly accused of cheating, for instance, there's no clear process to challenge that decision. There's no real appeal system, which can seriously affect their academic future. So yeah, again, I think AI in education absolutely has high risk potential, especially when it directly affects outcomes, rights, and also involves very sensitive personal data. And I think the challenge is finding this balance between leveraging tech whilst also protecting our students in the classroom.
Yeah, that makes sense. And I'm obviously based in the US. I haven't read too much about the UK's specific policies, or I'm sure they have many on AI. So I'm just curious, how do you see the balance between AI automation and human oversight when it comes to, say, grading or academic performance? Because I know that UK just came out with the AI Act, and it's pushing for explainability and fairness.
Yeah, I think that's a very important point. And I think so with the UK's approach, especially with the upcoming EU AI Act, it puts a big emphasis on explainability and fairness, as you mentioned, particularly when it comes to high stake areas like grading and academic performance. So if I take an example of AI powered student assessments, these systems can automatically grade essays, they can predict how students might perform in the future, and they can even suggest very personalized learning strategies. I think these systems are amazing, they're very efficient, but they also do get tricky very fast. And here, I think one of the biggest issues is the explainability. A lot of these grading models are basically what we call black boxes. So you put in a piece of work in and you get a grade out, but neither the student nor the teacher fully understands how that grade was decided. And I think when these decisions affect academic outcomes or university offers, that lack of transparency becomes a real problem. Now, under the UK AI Act, I'm sure you can understand that's a major red flag instantly. High risk AI systems are required to be explainable, meaning that they should really provide clear reasons for their decisions. So black box systems that can't do that, I think they're just really not going to cut it. And this is why I think we should really place huge emphasis on explainable AI or XAI. It's all about building, models that don't just do the work, but that can also justify how they work. Yeah, and so we spoke quite a lot about this idea, of explainability. And I think what's really interesting is explainability really cuts across both industries. So, as I mentioned, in education, it's all about fairness in grading. But I'm thinking in healthcare, it must be more about, having trust in the diagnosis or perhaps risk prediction. So I'm just wondering, how do you approach that at Omnitier, and what role does explainability play in your AI models? Because I'm sure that this idea of black boxes is just going to be tenfold more of a very serious concern in the medical side.
So, like at least tying in from before, explainability in at least our algorithm is definitely not where it should be, at least currently in my opinion. A lot of the emphasis is being placed on an algorithm that is more inaccessible and is more just for all data privacy, not able to be parsed through and checked how it works. So when we do parse or pass in, say, I don't know, 5, 6 patient data sets that are not supposed to be seen by anyone, we can't go through the AI and see, oh, okay, so it came to this decision based on this data that was in this patient's data set. So then we can point back and see, oh, look, we have access to this. The solution we have in place for that, we don't have any sort of legislation, at least as strong as the UK AI Act, at least in my opinion, yet. I'm sure it's coming. But at least as of this moment, the most we do is we output data sources. So instead of saying, this AI made this particular decision for a percentage of or probability of disease based on this specific factor that was in this patient's data set, we'll say, okay, this patient has a 95% pathogenic variant here based on this past data that we see could be relevant. So using public data sets, we can kind of say, okay, we know that this patient has something related to, say, these past 10,000 pathogenic variants. So that's how the AI came to this conclusion, rather than pointing to something specific in that patient itself. So it's kind of like a workaround to, not keep some data private, but it's definitely not as helpful as, just pointing directly to this is the cause, you should do something about it. Who cares if it's exposed? Which, is obviously a controversial topic in itself. And I'm sure that's a topic that could be a complete podcast by itself. But yeah, that's the way. And the reason why I would say that's important for our specific appliance is because we actually sell an appliance with that algorithm on device, and we send that appliance to, say, whatever customer needs it, rather than a lot of companies these days who have data centers that have that machine that runs that algorithm, and the user can never walk up to that machine and check it out and go through its code. Our code is encrypted, but technically we do send it out. So if you were able to get our decryption algorithm and all that, you'd be able to see all the code, and then we don't want any sort of leaks to happen from there. So we don't keep any of that data on there. We don't point to anything specific. That's it's a pretty cool system, but always room for improvement.
Yeah, that makes complete sense. Especially, I think it's really important to strike a balance between, keeping patient data private and still offering, I guess, some level of traceability in the decision making. It's definitely a complex space, and like you said, it probably does deserve its own podcast. But that actually brings me to something else. So, since AI is starting to play a bigger role in diagnostics, do you think it should ever have like the final say in a diagnosis? Or should it always be there used more of like a support system for doctors and not fully replace them?
Yeah, so this is probably one of the bigger questions in the medical field as a whole today, I would say. But so there's a big concept, at least you learn in university and a lot of these new classes that cover AI and ML and how it's all based on the objectivity of AI versus the subjectivity of humans, and whether we want pure objectivity from using an AI model, or we want some sort of subjective, interpretation by humans, or what sort of mix we want there if we do want one. So I think that the medical field always, people in general feel safer and feel more reassured if there is a human, looking at the data of, say, an AI output, or looking at their chart, or a human is the one making a decision, because a human treating another human just makes sense rather than a machine diagnosing or treating another human. There are some fields, obviously, like mathematics or physics, where the objectivity of AI is extremely important because it's able to think by itself. It's able to come up with ideas, and obviously humans afterward can go and research those ideas and further that. But those are sort of fields where objectivity is more emphasized, and I think that's important because those fields are how we further the scientific world in general. For the field of medicine specifically, personally, I think an AI would do a fantastic job of diagnosing a patient because, like I said, it's purely objective. It takes all the patient data, compares it to what the data has, and gives you a percentage or some sort of output of whatever you're looking for based on that data and that data only. No bias. We see, like you mentioned, bias in your previous answer with how AI is being used to monitor students. There's also a lot of discussion in bias in AI models in the healthcare field as to whether when we submit racial data or we submit like age data, whether it will use that data and say, okay, well, this person is African American, this person's Asian, maybe they're more likely to have this disease or this disease. So in my opinion, diagnostic-wise, I think AI would do a fantastic job, specifically because it's objectively looking at that data. But after that diagnosis, treatment or the patient's needs itself, because each patient is different, of course, all of that should lie in a human's hands. Who's to say what the best method actually is? But there's definitely a separate use case for objective thinking AI in healthcare and how it can be useful versus subjective thinking humans and how they can help out patients in a specific circumstance. It's a very delicate balance, and I think over time it will definitely come. We'll definitely all see how that comes to be and how AI is integrated with basically every aspect of every field. So I don't know. It's a cool future.
Hmm.
I'm up for that balance. Let's see what happens. But yeah, I mean, related to that, so when it comes to these AI powered education tools, do you think, as you were saying before in your previous answer, do you think personally that AI should have the final say on, say, student assessments, whether they were cheating, or it should be specifically teachers, or a balance? How do you think that relates to the education field?
Yeah, I mean, I think it's really similar to the medical space in that sense. AI can be incredibly powerful, but when it does come to something as personal and I guess life shaping as education, it should definitely not have the final say. Nowadays we have AI driven admissions, for example. Some universities actually already are using AI to screen their applications and evaluate personal statements of these students and even predict their future success. But again, I think this really opens up a lot of high risk territory when we consider these systems. Now, there's the transparency issue here because students often don't know why they were accepted or rejected. And again, if there is a mistake, if a mistake happens, there's no clear accountability. Who do you even go to? It creates this mistrust for students and not only students, honestly, parents and schools as well. Plus, some of these models go beyond academic data and, they really start pulling in personal information, even social media activity in some cases, which raises very serious concerns around, I think, data privacy and profiling. That's why I think AI in admissions would likely be, classified as very high risk when the EU Act is put in place and would require not just human oversight, but also really clear explainability and accountability structures. So one of the things being proposed currently is this idea of having an AI officer within institutions. So this is someone who is responsible for overseeing how the AI is being used to make sure that these decisions are fair, explainable, and also challengeable if they're needed. All right, so that brings us to the end of this episode 2 of the Bava.ai podcast. Nadish, thank you so much for joining me today. It's been an absolute pleasure, and it was wonderful having such an insightful conversation with you. We touched on some key areas from AI being applied in genomics and the challenges around explainability and data privacy to more broader implications of high-risk AI under frameworks like the EU AI Act. I think what stood out the most is how these issues aren't just limited to healthcare, but also the education landscape also faces many of the same questions around, fairness, accountability, and human oversight. So again, Nadish, thank you so much, and I really appreciate you sharing your perspective today.
Yeah, like I said from before, there's a lot of definitely tangential topics that we could talk about coming from this. I appreciate being on this podcast. Hopefully, I can be on another. And yeah, I liked hearing the insight on your side and the education side. Definitely different from bioinformatics, and I hope there's just more to see in the AI field. We'll see what happens.
Thank you.